everyone, and welcome to my lab. Are you ready to learn? Are you ready to have some fun? I want you to pay close attention to everything that's going to be happening. I don't want anyone to miss out on the excitement that we have when we do science experiments. We do them safely. I want you to look and see that I'm wearing my eye protection. I'm wearing my goggles, and I want you to see that I have a fire extinguisher right here, ready to be used, just in case something goes out of control. We're not planning on anything going out of control, but we have it as a safety precaution. You and I know where it is. I'm going to set it on the side here. It will be used if it is necessary to use. Now, when you came in to my lab, you saw lots of different items on the tabletop. You also saw, and you see right now, that we have some things up in the air. What do we have up in the air? Well, how many balloons are there? 6. And are they all the same color? No. What do you suppose you might say if I ask you what's in the balloons? What might you say? Well, some of you are saying helium, and some of you might be saying there is a gas or gases lighter than air. That's why the balloons are tethered. They're up where they are. I'm going to tell you now that helium is a gas lighter than air, but does not burn. What we have here in this torch and in the candle are two examples of what we call a controlled combustion reaction. The wax in the candle is burning, and the natural gas, actually it's not natural gas, it's propane from this bottle that is burning. So what I'm going to do is try to find out what's in these balloons by putting the torch to this green balloon. Remember now, helium is a gas that does not burn, so we're going to find out what's in this balloon. I see some of you are covering your ears. Why are you covering your ears? Because you might expect that there might be a loud sound. So let's find out and see what's going on. Here we go. So what happened? The balloon popped, right? And the flame went out, right? That balloon had in it the gas helium. In science, we always repeat the experiment. So that's what I'm going to do now. Repeat the experiment. You ready for this? Here we go. Did the same thing happen? Exactly the same thing? Yes, and the flame went out. So those two balloons had in them the gas helium, and helium does not burn, does not get ignited. So we've got a yellow balloon here. Let's find out what's in this balloon here. You ready for this? Here we go. Did that balloon have helium in it? That balloon had in it the gas hydrogen, which combines with oxygen from the air in an uncontrolled combustion reaction, which is what we just saw. And what do we always do in science? Let's repeat the experiment now, and let's do it in the dark. With the lights down, please. Let's do it in the dark. Here we go. You ready? Yeah. Did you see that ball of fire? Did you see it better with the lights on or with the lights off? That's why when we do experiments that release energy in the form of light, we do them in the dark or in a darkened area rather than outdoors. And now I want you to watch the monitor because we're going to have a slow motion playback of the uncontrolled experiment we just saw. There's the flame. You won't hear any sound. There's the flame, and there is that ball of fire. Did you like that? Yeah. You noticed that when we moved from the green balloons to the yellow balloons, there was this change in the amount of sound energy that we received, right? So we have 2 more red balloons, and we have lots of other experiments to do. What should I do next? More balloons or start with the other experiments? More balloons. All right, we'll do more balloons, but you and I obey the safety rules. And that's why I want each one of you to take both fingers like this and stick them in your ears to protect your ears from ear damage. I cannot do that and do the experiment at the same time. That's why I'm going to use this for my ear protection. All right, so here we go. That balloon had in it a mixture of hydrogen and oxygen. It had more oxygen than is what's in the air. It had more than 20% oxygen. What do we always do in science? Protect your ears. We're going to do this in the dark. You ready for this? Let's have a look at that last uncontrolled combustion reaction in slow motion. You won't hear the sound, but you'll see there's the flame. There is much faster than the previous one. Did you like that experiment? All right. Now I move over and do a different experiment. This experiment actually, well, you know what? I need the directions for the next experiment. This is a book that I wrote with my co-workers. And what I'm going to do, with your permission, is open the book and read the instructions for the next experiment. So bear with me as I do this. This is not an ordinary book. This is a real hot book. It's actually not a book at all. It's just the book covers from Volume 5 in my chemical demonstration book series, published by the University of Wisconsin Press. Let me show you what's on the inside. On the inside, we have a battery, and a battery has stored in it chemical energy. And we have a filament from a light bulb, and we have a wick that I soaked with ladder fluid before you came into my lab. But I'm going to show you something else too. At the bottom right here, you see I have a small black button. Can you see it? Right. All right. So when I push the button, after I moved the book away from my face, the chemical energy changes into electrical energy, and the filament lights up. But this filament, like all filaments in all light bulbs except LEDs, gives off light energy and also heat energy. All right. You know about the fire triangle? The fire triangle, in order to have a fire, you need something that burns, that's the fuel. You need what? Oxygen. Yes, and you need all three things together. All right, so here we go. I take the book cover, open the book cover, move it away from my face, push the button. There it is, right? Now, you tell me now what happens when I close the book. What happened when I closed the book? No, don't raise your hand, just tell me out loud. Not enough oxygen. I opened the book now, there's oxygen right there. How come the book is not on fire? Remember the fire triangle. What do you need to have a fire? You need something that burns, you need oxygen, usually from the air, and then you need heat. You need a source of ignition. So I opened the book. What should I do next? Press the button. No, move it away from my face. Gotta push the button now, right? Move it away from my face. Now I push the button, right? Okay, there it is. And we teach about the fire triangle to learn how to put out fires, not to start fires. Do you like that experiment? For my next experiment, I'm going to use a flower pot. This flower pot has in it two solids. It's a mixture of iron oxide, rust, and aluminum. And they're powdered solids. They're not finely powdered, but you can see that they're there, okay? What I'm going to do is carry out the experiment in that big box on my right. And I'm going to activate the mixture by using this sparkler. And to activate the sparkler, I have to turn the gas on to light a burner. All right, and I need to have a very hot flame. So there's my flame. Some of you can hear it roar a little bit. Now what I'm going to do is take this sparkler, put it in the flame. When it starts sparkling, I'm going to move over to that box and put it in the mixture of iron oxide and aluminum. And we're going to do this in the dark, but not quite yet. Let me get this going. There we go. OK. There we go. All right. Here we go. With the lights back up, please. Lights back. Lights up. This is a highly exothermic reaction. It releases a lot of energy in the form of light, which we saw in the form of heat. In fact, what you saw was a very thin amount of molten iron, a stream of molten iron coming down. Let's take a look at this last reaction on the monitor in slow motion. Let's see what we see. A lot of smoke, a lot of heat. There are the sparks. And you'll see the molten iron coming down. Let me show you now, using this pair of tongs, let me show you what was collected in the bucket of sand. Very red hot iron. The temperature was so high, it melted the iron, and actually some of it is stuck on the tongs here, so we have more sand. I'll put it right there. This is called the thermite reaction. For my next experiment, I'm going to use this piece of copper. It's nice and shiny, as you can see. It's sitting on top of a tripod, and underneath it is a burner. I'm going to turn the gas on and light the burner because I want to heat the piece of copper. So turn the gas all the way up and start heating the piece of copper. And you watch carefully and tell me if you see any changes. Is the surface of the copper changing at all? Huh? You're saying yes, you're nodding your head, right? You see the surface is getting darker or getting shinier? It's getting darker, right? That's because the hot copper surface is reacting with oxygen that's in the air to give us a thin layer of copper oxide. And if you look carefully at the top of the flame, you'll see there's some green coloration too, which is characteristic of heating copper. So the shiny aspect of the copper has gone, and now we have this black deposit of copper oxide. The next part of this experiment has to be done very carefully because I'm going to use hydrogen gas from this tank. And before I use the hydrogen gas, I want to turn off the burner completely, and I'm going to turn the hydrogen on. You see it's flowing out of this funnel. I'm going to bathe this with hydrogen. And now you see the color changing back, some of it, the copper. There's copper oxide. Hydrogen. There's copper. Copper oxide. And this can go on as long as the copper is hot enough for the reaction between the copper oxide and the hydrogen gas to give us back copper and some water vapor. So I'm going to turn this off now. At this time, I would like you to welcome my longtime colleague and friend, Dr. Rodney Schreiner. Rod? Right.
Hello, Bassam.
Happy to see you.
I'm happy to be here and celebrating this 46th anniversary of your program. It's wonderful.
Thank you. Thank you. Thank you. I'm very proud of that. Thank you.
You know, Bassam and I are chemists, and we like to celebrate anniversaries with the element that corresponds, the element whose atomic number matches the anniversary. Do you know which element is number 46?
Palladium.
Palladium,
Palladium
yes.
is the element, yes.
And because palladium is element number 46, in honor of this, I brought a sample of palladium for you.
Wow.
And it is a silvery metal, as you can see.
Yes.
I didn't bring very much of it.
How come? Is it expensive?
Palladium is very expensive, yes. I checked the price of it just on Friday, and it was $540 per ounce. So this vial contains 1 gram of palladium, which is worth about 30 bucks.
Do I get to keep it?
Yeah, of course, it's for you.
Okay, thank you, thank you.
You know, one reason palladium is expensive is that it is very useful chemically. In fact, most of the palladium that's produced every year is used in the catalytic converters in automobiles.
What does that do?
Well, it helps to convert the gases, the poisonous gases that come out of the engine, into less harmful and safer chemicals.
It's better for us to breathe then.
Right, and we don't get smog and all sorts of other kinds of pollution in the air.
Less pollution.
Right. So palladium is valuable as a catalyst, and I want to show you it working as a catalyst, not in an automobile converter, but with another gas.
All right.
So I have a reactor here. I have a reactor, which is a little beaker, which has an arm that goes down to the bottom. And I'm going to use hydrogen gas in this container. It's the gas which palladium is going to work as a catalyst. So we need some hydrogen. Is this open? Oh, it is, but that's too much.
Too much?
That's too much. Let's turn it down, because we all know hydrogen's quite flammable, and we don't want a really big fire. We want just a little fire, but there you are. So now you can hear hydrogen is flowing through this beaker, goes on the side, down to the bottom, and then comes out the top. I can actually feel it here, and you could hear it. And nothing is happening, because there's nothing there to ignite it.
But you said you have a catalyst.
Yes, I'm going to turn this off.
Turn it off.
Yes.
Okay.
Make sure there's no hydrogen in it.
All right.
And here's the catalyst. It's palladium black. So this contains the same material as that, but rather than being pure metal, it is the metal coated on carbon. So it's going to look different than the metal. It won't look like a metal, but it is palladium. And there's actually less palladium in this bottle than there is in the vial. So I'll put some of this catalyst in the bottom. And you can see it's black.
I see the black coloration, yeah.
And now I'm going to turn the hydrogen back on. And let's see what happens. No heat, just palladium catalyst.
Whoa. What happened?
Heat.
You just turned the valve?
I just turned the valve.
So you let the stream of hydrogen in?
Yes, and it, wow.
What's the palladium doing?
The palladium is making the reaction and beginning the reaction between hydrogen and oxygen in the air. So the hydrogen is burning in air. And we might be able to see this better in the dark. So if I could have the lights down, I will turn on the hydrogen. There, nice big flame. Turn off the hydrogen, flame goes away. No heat now, turn on the hydrogen. Yeah, I agree. Wow. Thank you. I've been doing an experiment with another metal here. This metal is iron, much less expensive than palladium, and it's in the form of a pipe. And what I've discovered with my experiments is that I can make sound with this pipe by passing gas through the pipe. But it needs to be one hot gas, and it needs to flow very fast. So one way we can get that is with a burner. Here's a burner. And I will ask you to light the burner.
Light the burner?
Yes.
Okay.
Okay, the burner's on, so that's hot, and it's gas flowing very fast, and I will have it go through the pipe, and you can hear a little bit of noise, sound of the gas going through, but you can probably hear it better if the torch isn't on, so I'll take the pipe off, and we get this nice sort of deep whistling sound. And it goes on for quite a while. But it doesn't continue forever. So eventually it runs out of hot gas and it stops. There you go. But while I was doing this experiment, I discovered I can pour sound.
You can what?
I can pour sound. It's like pouring water from a cup.
No way.
I can pour sound, yes. Want to see?
Yeah, I want to see.
Okay, well, so we need sound first, so if you'd like the torch.
Back to this?
Yes. Let's get some sound from my pipe. And I can tell when it's, the gas is really hot and flowing through because I can feel it's getting warm here. That's probably warm enough. And now I'll pour some sound into this cup. And then I'll pour it back. Into the cup. Pour it back. Into the cup. Another thing I discovered is sound is invisible, so I can't tell if I'm spilling it. I must have spilled it because it's all done now. I admit that's a bit of a trick. There's actually some science behind what I'm doing. Do you want to know how this works?
Yes.
This pipe is not an empty pipe. There's actually something inside. Near the end of the pipe, ooh, that's hot. You know that? That's hot. Near the end of the pipe is a gauze. Let's see, can I get you there? Perhaps you can see that. There's a gauze, a metal gauze inside. And when I put that over the flame, the gauze gets really hot. And let's do this again.
Again.
When it gets really hot, as it is right now, getting hot, when I take it off, the hot gauze heats the air, makes it less dense, and it rises through the tube. If I turn the tube sideways, it can't rise. But if I hold the tube vertically, it can rise. This cup had nothing to do with it.
Thank you very much, Ed. Thank you. My next experiment is going to be done using these plastic bottles that have screws stuck on the side, and there's a cork on top, but the screws are not touching on the inside. Let me show you a cutout of what we have there. You see, the screws are not touching on the inside at all. Each one of these two plastic bottles have a small amount of a clear and colorless liquid in there, and this liquid has a vapor pressure. And I'm going to use a device that generates a spark. It's called a Tesla coil. There's a spark that's coming off here. You can't see it right now, but what I'm going to do is touch one of the screws and see if I can make the spark jump across the gap that separates the two screws, and we'll see what happens. You ready for this? Here we go. Whoa. And let's do it again. Whoa. You like that? Yeah. Are you ready? Are you sure you're ready? You've been a great audience, helping celebrate this very special anniversary. And I want you all to remember, no matter what you do, as you do the experiments carefully, to be paying attention to what goes on, and to also remember science is fun. Thank you all very much. Thank you. Thank you.